Okay, so hello everyone. Today we are going to talk about the differential equation with a non-homogeneous equation. So we introduce ourselves first. My name is Hani Abdullah Nahadi. My metric number is 195456.
Hi, my name is Ki Sungwin and my metric number is 195901. And today we are going to talk about the application of the non-homogeneous equation, which is in three main fields we are going to talk about. So for first one is aerodynamic, second one is vibration, and third one is the fluid, some part of fluid.
Okay, so that three thing is not just the overall of the differential equation. It still have more, but that three thing is just the normal basic one. Like the example in dynamics, like in the topic of the kinematic of particles, if we want to, we have the distance. If we want to find the velocity, we can differentiate the distance, so we will get the velocity already. And if we want to find the acceleration, we just differentiate the velocity, so we get the acceleration already.
So like you said, sometimes we get the acceleration. So from acceleration, we want to find velocity, we have to integrate it. So from the velocity, we have to find the distance, displacement, we have to integrate it again.
Yeah, so that is just the basic of the differential equation. And now we're gonna show you one of the example of the differential. Okay, so now let's begin with our question. So this is the differential equation. Look like this. So first we look first, is it homogeneous or non-homogeneous? This one is non-homogeneous because it's not equal to 0. So we're gonna have YH and YK. First we want to find YH. So YH, we put this thing equal to 0. So it will become, if second order will become R squared. First order will become minus 2R. If don't have any order, only the constant left. So will become this one equal to 0. So now we want to find the value of R, which has two ways. First thing is the blanket. We do the two blanket, but this thing cannot. So we have to use the actual formula, which is minus b plus minus square root of b squared minus 4ac over 2a. So we know that a is 1, b is -2, c is 4. We just substitute a, b, and c into this formula. So we get this one. When you eliminate it, you will get square root of -12, 2 and 2. But under square root cannot be negative, so you have to put I. So it will become 2 over 2 plus minus I, like I said. Square root 12 is 2 square root 3 over 2. So you just cancel it. Cancel, you get 1. You cancel 2 and 2, you get 1. So the remaining is 1 plus minus square root 3 I. Okay, so we know that gamma plus minus beta I. So this is what we get, 1 plus minus square root 3i. So you just compare. When you compare it gamma equal to 1, beta equal to square root 3. Okay, so now we want to know the YH. Let's go for the table. This is the table for YH and also YK, but we look for the YH first. First case, if R1 equal to R2, like maybe when up for this one, you get like example like R1 you get 2, R2 you get like 4, so you have to use this one. Second one, R1, the second case, R1 equal to R2, like maybe R1 equal to 2, R2 equal to 2, also equal to 2, so you have to use this one. But in our case, it's gamma and beta, so we have to use the third case. Third case is this one. In our case, it will become exponential of gamma x, a cos beta x plus b sin beta x. But in our question, it's not x, it's t. So we just put t instead of x, just that. No need to change anything. So from this, it will become So our YH will become E, gamma is 1. Like I said, put T instead of X, so become 1T, so E exponential of T. A cos beta is square root 3 beta T plus B sine beta is square root 3 T. So this is the YH value. And now my friend will explain about the YK value.
As my friend mentioned just now, this one is a non-homogeneous. So we have 8 for YK we have 8t minus 12 sine 2t. So from the table here, we know that for this case, YK equal to ax squared plus bx plus c. We can use for this one 8t. Then for the second case is a exponential. So we no need to use in this question because we don't have the exponential. So now here for the YK here we have negative 12 sine 2t. So we have to use this case for the third one. So from here we take this one, put here a YK1 equal to a cos kt plus b sine kt, because we want to use negative 12 sine 2t as our YK1. So y equal to a cos 2t plus b sine 2t. Then differentiate, become negative 2a sine 2t plus 2b cos 2t. Then differentiate again, negative 4a cos 2t minus 4b sine 2t. So from here, from the equation, we know that y double prime negative 2y prime plus 4y equal to 8t minus 12 sine 2t. So for y double prime we have here, we already found it. Just put this thing in here, just substitute inside, then minus 2y prime. Here, from here, we put inside, plus 4y, this one, put inside, equal to 8t minus 12 sine 2t. So we substitute, then we get here, we split into 2, because we have cos 2t and sine 2t. We split into 2, cos 2t and sine 2t equal to negative 12 sine 2t. Okay, sine 2t and sine 2t, this one we put here equal to this one, negative 12 here. So negative 4b plus 4b, eliminate. We only have 4a now. 4a equal to negative 12. So a equal to negative 3. So from here we substitute a into this one, cos 2t, negative 4a, negative 3, minus 4b plus 4, this one is a. From this one we substitute inside this one, so we get 12 negative 4b negative 12 equal to 0. So b is equal to 0. We know that YK1 is equal to a cos 2t plus b sine 2t. So a we have it, negative 3, and b is 0. So just only here, negative 3 substitute into a, become YK1 equal to negative 3 cos 2t plus this one all 0. So we no need to write it here. Okay, now we are looking for YK2. Here is the YK2, 8t. So we know that YK equal to ax squared plus bx plus c. So our t here don't have the power. So meaning that our YK equal to ax plus b. Okay. So from here yk2 equal to at plus b from the table just now. So our y equal to at plus b. Differentiate become y prime equal to a. Then differentiate again become y double prime equal to 0 from the equation. So y prime negative 2y prime plus 4y equal to 8t. So substitute y double prime here is 0, put here 0 minus 2y prime equal to a plus 4y, y is at plus b, substitute into this equal to 8t. So here is t and t, so become 4a equal to 8, a equal to 2. So we know that our a is equal to 2, we substitute into here, negative 2a 2 plus 4b equal to 0. So 4b equal to negative 4 here, bring it here, become 4. So our b equal to 1. So yk2, we substitute the value here 2a into this one, become 2t plus 1 equal to b equal to 1, b equal to 1. So our yk combination between yk2 and yk1 here become yk equal to 2t plus 1 minus 3 cos 2t.
Okay, so now we got yk1, yk2, and yh, and then we're gonna combine. So y is equal yh plus yk, which yk is 2t plus 1 minus 3 cos 2t, and yh is e power of t a cos square root 3t plus b sine square root 3t. So we just combine two of this. It will become et, this thing is yh, and this one is yk. So we combine already. And if you see properly from the question, it has a, what's called, I think it's a limit. This one, initial value. When y0 equal to negative 2, which mean that when y0 equal to negative 2, which mean that y is negative 2, and whatever in this, which is t is 0. So y is negative 2, we substitute negative 2 here. T is 0, whatever is t, we put is 0. So we get e power of 0, a cos 3t 0, plus b sine square root 3 0, plus 2 0, plus 1 minus 3 cos 2 0. Negative 2 remain. Exponential power of 0, you get 1. Cos 0 is 1, so 1a. Sine 0 is 0. This one gone. So the last you will get 1. Cos 0 is 1. 3 times 1 is 3. So you will get this one. And then when you eliminate it, you will get this. When you move 1 and 3 to the other side, it will become 0. So 1a equals 0, a equals 0. Okay. So when a equals 0, which means this term is gone. So you will get b sine 3t. I bring exponential inside. So you get this plus 2t plus 1 minus 3 cos 2t. Okay. One is done. Second one. Y prime 0 equal to 8. But if you see, we get only y. So we have to differentiate this one. So I will show you. This one become, when you differentiate, you see this one? This one? It's a product rule. So you will get this, b sine square root 3t exponential t plus exponential t square root 3. Differentiate sign, you get cos. You have to diff inside again. You get diff inside this one, you get square root 3. Okay, first one done. And the rest is just no more differentiate. Differentiate 2t, you get 2. Differentiate 1, 0, gone. Differentiate 3 cos 2t, 3 cos 2t, differentiate cos become negative sign. Negative, negative become positive. So positive. Cos becomes sine. Differentiate inside, you get 2. 2 bring out, when 2 bring out, made the 3 1 become 6. So you get this. And then from what we know that y prime 0 equal to 8. Like I said, like the previous one. Y, this is y. And this 0 is t. So from this, oh, this is y prime. So from this, y prime is 8. Whatever t in there, we substitute is 0. So b sine square root 3, 0. Exponential power of 0 plus exponential of 0 square root 3 b cos 3 square root 3, 0 plus 2 plus 6 sine 2, 0. 8 remain. Sine 0, 0. Exponential 0 is 1. 0 multiplied by 1, 0. And then this one. Cos 0 become 1. Cos 0 become 1. Exponential 0 become 1. Square root 3b times 1. Square root 3b. Plus 2 remain. Sine 0, 0, 0. And then move 2 to the other side, becomes 6. 6 equals square root 3b. So b equals square root 6 over square root of 3. You can answer like this, but normally we don't answer this way because we don't want the square root to be the denominator. So we multiply by square root 3 over square root 3. So you will get 6 square root 3 over 3. Eliminate that, you get 2 square root 3. So we got A, we got B. So the final answer, this is y, right? So the final answer will be y equal. We know A is gone, so we are not going to touch with A. So B, 2 square root 3 sine square root 3t exponential t plus 2t plus 1 minus cos 2t. This is our answer. Thank you.
Okay, so now we come to the conclusion. So for the differential equation, we have a lot of method to do. So for the first one, we have Euler. Second one, we have the operator method and
Separable method. So
okay.
yeah, separable. And yeah, and for the differential equation, we can use widely for a lot of applications, such as we mentioned before. Some part of fluid, some part of aerodynamics, and also vibration. But in that particular thing, in that particular problem, we have to see first what method we have to use. Like my friend have said, we've got a lot of method. So I think that's all from us. Thank you very much.
And have a good day.